Today we're at the Florida BrainLink Initiative in Delray Beach, Florida. It's a clinic where we use transcranial magnetic stimulation for neuromodulation. It's used for a number of different things, but in particular we're using it to rehabilitate patients from stroke that have ongoing weakness that has not responded to other kinds of therapy. What we utilize here is a science called connectomics. It's basically looking at how the brain is wired, and by understanding how the brain is wired, we can tell if any of the wiring or any of the ways that the brain is talking to itself has been made abnormal by a stroke. If it has been, then we can modulate those circuits or alter how those circuits are working by using transcranial magnetic stimulation to change how the circuits talk to one another. Neuromodulation has actually been around for many years. It's been done in a variety of different ways, some with electrical stimulation. What we do that is very different here than has ever been present before is the fact that we map out the brain, and by mapping out the brain, we can identify exactly where the issues in the brain transmission are. And by being that particular, by homing in on exactly where the problem is, we can more directly attack the problem itself, which should yield better results in the long term for the patient. Well, neuromodulation can actually be used for a variety of different problems that can occur within the brain. Basically, any of the brain's functions can be affected by injury or by stroke, and neuromodulation can be used to try and remedy the problems that occur from either injury or stroke. At the present point in time here at the Florida BrainLink Initiative, we're particularly looking at problems that have been created by stroke. The first and most obvious one for most patients is weakness. Many patients, after their stroke and after normal rehabilitation, have been told that they need to live with the deficit that they're left with, which is often weakness in an arm or a leg, problems with walking. And what we found is that using neuromodulation, we can hopefully improve the function even if the stroke has been months in the past, and the end result is that a patient regains some function that they never thought they'd be able to gain back. Transcranial magnetic stimulation is actually a way that we can alter and modulate the circuits in the brain. There's a coil that's placed over the skull. There's nothing that passes through the skull other than energy. So there's no drilling, there's no incisions, there's no shaving of hair. But what the magnetic field does is it creates an electrical field, and that electrical field can have an effect on the brain for about an inch or an inch and a half under the skull. Fortunately, a lot of the function of the brain resides in that inch to inch and a half under the skull, and so we can have an effect on the cells that are very important in either the function that's been impaired, or we can identify cells that haven't been impaired. The way the Florida BrainLink Initiative does treatment is very new and very different from what has been available before. A patient gets a MRI that appears to be a routine MRI in terms of what the patient feels and sees. That MRI is sent up and processed in a supercomputer, and basically what we get to see is how all the areas of the brain are communicating with each other. What many of us don't realize is that our brain is in constant communication with itself, and disruptions in that constant communication is what basically shows itself as deficits in weakness in speech and vision or any other aspects of neurologic function. So by being able to specifically identify those problems in communication and then being able to try and modulate those circuits so they work more normally. With more normal function in the circuits, we see return of function in terms of what deficits the patient may have had before treatment. So here at the Florida BrainLink Initiative, we use something called navigated TMS. Basically, by using what, I hate to say it, but is actually a GPS like you have in your car, we can make it so we can recognize the areas of the skull and the areas of the brain. By being able to do that, we can exactly target the TMS for the area or abnormality that we've identified. Almost the same way as you would put a destination in the GPS in your car and it ends up taking you there. We do the same thing but on a different scale and for obviously a very important and different reason. Connectomics is a new and growing science where we are learning how the brain is connected. There's two very important distinctions there. One is what we call structural connectomes, which is literally showing how the brain is connected in terms of areas to different areas, sort of like a bridge between two different boroughs in New York. The second and almost more important thing is what's called a functional connectome. And that is literally not just showing how things are connected, but it's showing how the different areas communicate with each other. And it's those alterations in that communication that is changed by stroke, and that alteration in communication is what we're trying to fix. The future of neuromodulation is about as broad as you can think it is. The brain is a remarkable organ. As we understand more about connectomics, we're understanding more about the brain function, and any alteration in brain function, from stroke to injury to Alzheimer's to any alteration that you can think of, has the possibility of having a footprint, of being identified by the science of connectomics. Once we identify that footprint, then the potential of being able to treat a deficit that's caused by any one of these different diseases or injuries becomes possible. So literally, the field of connectomics is growing daily, weekly, and monthly, both here and with colleagues across the nation and across the world. For years, the brain has been thought of in an anatomic way, and what that means is that the brain has been split up into different regions: frontal lobe, parietal lobe, occipital lobe. And what we've learned with connectomics is that the brain that we've thought of anatomically and just structurally, actually functionally, is very different. That there are areas of the brain that communicate with each other that may not be next to each other and may be separated by distances on the orders of millimeters or inches. And the term that's been coined is areas that fire together are wired together. And basically what that is saying is that the brain has different networks that combine to make us who we are and to allow us to communicate and walk and act and see and basically do any function that you can think of. And so now that we understand that the brain is more than just this structure, it's more than just a building that's standing there. It's a living, breathing, cooperative organ where all areas are talking to each other. It allows us to better understand both how the normal brain works and then how a brain that has been injured or diseased works. When you take all of that information together, then we can use TMS or transcranial magnetic stimulation to aid, affect, or alter that communication and trying to restore it back to more normal state.